Hey guys, it's Mr. Brengle, and today I'm going to be going over a VIRP chart for a combo circuit. You can see here that I've already entered some of the values. We have a 12-volt battery, we have a 10-ohm resistor in series, and then we have an 8-ohm and a 12-ohm resistor in parallel. So I've entered the resistances here and the total voltage down here. We're going to go ahead and start solving. So the first thing we want to do is find the total resistance of the circuit. So I'm going to zoom in over here on our total resistance box. And our total resistance is going to be calculated by adding the resistance in series to the resistance in parallel. So the first thing we have to do in order to do this is to find the resistance in parallel. So the resistance in parallel is equal to 1 divided by 1 over 8 ohms plus 1 over 12 ohms. When you do this calculation, it should give you a parallel resistance of 4.8 ohms. Now, we're not done because remember, to find the total, we need to add that to the series resistance. And the series resistance was 10 ohms plus the 4.8 ohms that we calculated for the parallel portion, which means that our total resistance is equal to 14.8 ohms. Okay, so now that we have our total resistance, we can then calculate the total current because we also have the total voltage. So let's go ahead and do that. Total current is going to be equal to the total voltage divided by the total resistance, which in this case is going to be 12 volts divided by 14.8 ohms. And when you do this calculation, your total current is going to be equal to 0.81 amps. Okay, so the next step would be to figure out what is the current of the series resistor. And the reason for that is because we don't even have to do any math for that. We know that in series the current is the same everywhere. So as the electrons are traveling through this circuit toward this resistor, you've got all of the current coming through this resistor, and then as it comes around, then it gets split when it goes into the parallel section. So what that means is that our total current is going to be the exact same as the current at the series resistor. So this is also going to be 0.81 amps because of that rule in series that the current's going to be the same. So now, since we have two boxes here, we have our resistance for the 10 ohm resistor, we have the current for the 10 ohm resistor. Let's go ahead and calculate the voltage at the 10 ohm resistor. So this calculation should not be too difficult. It's just V equals IR. So the voltage at the 10 ohm resistor is equal to the current at the 10 ohm resistor times the 10 ohm resistance. So this is going to be 0.81 times 10, which comes out to be 8.1 volts. Okay. Now, the next thing that we're going to want to do is we're going to want to take a look at the voltage. What does that do to the voltage at the parallel resistors, right? So basically what we're saying here is that we're dropping 8.1 of the 12 total volts at this resistor. So we need to subtract 8.1 volts from 12 volts to find out how much voltage is left for this portion of the circuit. So come back over here, and this calculation will be the same for both of these, but we're going to do 12 volts minus 8.1 volts, and that is going to be equal to, so the voltage of the 8 ohm resistor is going to be 3.9 volts, and the voltage of the 12 ohm resistor is going to be equal to 3.9 3.9 volts. Okay, now that we have two pieces of the puzzle, and I'll zoom it back out here so we can take a look, we can now calculate the current for the 8 ohm resistor and the current for the 12 ohm resistor. So since these are in parallel, the current should be different going through each of the branches. You should have more current going through the 8 ohm resistor and less current going through the 12. So to calculate this, the current is equal to the voltage of the 8 ohm divided by the resistance of the 8 ohm. So this is going to be 3.9 divided by 8. This would be volts and ohms. And that is going to give you current at the 8 ohm resistor is equal to 0.488 amps. And we're going to do the same calculation down here. Current at the 12 ohm resistor is equal to the voltage of the 12 ohm divided by the resistance, which is going to be 3.9 volts divided by 12 ohms. And this is going to give us the current at the 12 ohm resistor, which is equal to 0.325 amps. Okay, so now we've basically finished everything that involves current and resistance and voltage. So you want to make sure that the current in the 8 ohm and 12 ohm resistor, which are in parallel, add up to 0.81. And they do in fact add up, and just remember that with rounding it's going to be slightly off, and you won't be counted off for that. Okay, so just the very last thing that we would want to do here is calculate the power of each of these. So let's come over here and we'll just write the equation down. So remember that power is equal to current times voltage. So let's scoot this over here so we can see all of our values. And when we plug this in, it's going to be 0.81 times 8.1. And the power here is going to be equal to 6.561 watts. Power down here, power is equal to 0.488 times 3.9 volts. This is amps, by the way. And that's going to give us a power of 1.903 watts. Scroll down here. For the 12 ohm resistor, the power is equal to 0.325 amps times 3.9 volts. And that's going to give us a power value of 1.268 watts. And then finally, our total power here, which is going to be equal to 0.81 amps times 12 volts. This is going to give us power of 9.72 watts. Okay, so once again, when you add up all of the powers, when you add up these three powers right here, they should total up to be almost exactly 9.72. Again, with rounding, they're going to be slightly off. As long as you can complete this without looking at anything else, you should be good to go for the VIRP portion of the quiz over combo circuits.